I'm Jessica Kerr, Jessitron, and Codebeam will forever be a special conference in my heart because Avdi and I got to keynote last year, and it was the last conference, and so it's the last conference. So I'm happy to be back this year. I think you all know Chelsea because she keynoted a few minutes ago.
Hi, everybody.
And we are here to talk amongst ourselves, and by ourselves, I include all of you. This will be more fun with your contributions. So pipe up in the chat. Let's see if I can make the chat show. Is there, how do we see the chat? Okay, I can see it over there on Huva. Or use your voice. First of all, how many people expect this to be about security? Raise your hand if you thought this was a talk about security. I see at least one. I saw questions in, if I open participants, I'll see some hands. Okay, so just a few. Okay, that's reassuring. Francesco actually asked us to talk about technical debt. And I was like, oh, can we not call it technical debt? Because I don't think most of what we talk about is technical debt. I don't think the metaphor works anymore. It worked when Ward Cunningham invented it at a finance company where they worried about debt, like 30 years ago when debt was considered a risk. But these days, in the days of VC financing and equity versus debt balancing, debt is not equated with risk. And that's why when I would rather talk about it as escalating risk. And I got that phrase from Artemis Starr in her talk. And I think it's much more apt. Chelsea, what do you think?
I think so. I think that you brought up a good point earlier when we were talking about technical debt, insofar as that the idea with debt is that you can throw money at it and pay it down. Which, if only that were true of the apps that I have worked on that were difficult to maintain. But a lot of times the problems are more nuanced than that. But the metaphor of debt suggests that all like escalated maintenance load on an application might have the same solution, the same way that all debt can be solved with money. And I think it ends up leading to misunderstandings about how to address a code base where it's difficult to change things.
Agree. So there's a different kind of risk that that developers see and experience and suffer from that's harder to explain. Go, share the screen. And there's my iPad, I think.
Yeah.
Okay. So when we talk about risk in software, security is totally one of the things that comes to mind. And that is one aspect of risk. And it's one the developers need to care about. I try to avoid it. I'm like, DevOps was enough. Now I have to think about like Linux and networking and all kinds of other things that I didn't have to know about before. Security too, but yes. And security consists of, let's see, CIAT is the acronym. So there we're worried about confidentiality, integrity, integrity, availability, and traceability. Traceability is like auditing, can you tell what happened, who accessed this data kind of thing. But on the development side, we also experience cost of operations. So, Chelsea, is that what you were talking about with the maintenance costs?
Mm-hmm.
And the cost of change, because what we call software maintenance is one, keep it operational, and two, make needed changes. I like to call it continual improvement instead of maintenance. I'd rather be on improvement duty than greenfield. And this is what's usually called tech debt, I think. In addition to bugs, which screw up integrity, and outages, which affect availability. All right, so with that definition of looking at tech debt as escalating risk, you can see that it's dangerous. It's dangerous in that the software may go down, and that would affect our business, or it may become impossible to change. There's a cat clawing behind my chair. And that's my favorite risk of tech debt, is that part of our job as software developers is, sometimes you take shortcuts and sometimes you don't upgrade your libraries. There's your security risk right there. But the thing to really watch out for is, do you ever get to the point where the cost of change approaches infinity? Chelsea, have you been there?
I have. I have not been working on an application where the cost of change approaches infinity, but I have been in apps where making even a small change required a fair amount of work. First, the context had all been lost on the application. So maybe the app was written, usually it's not, and I find that tech debt, we tend to have this idea that tech debt, there's a fly, tech debt, we tend to equate tech debt with like bad code. And I don't think that that's always been the case in my experience. I think that when we do equate tech debt with bad code, we can end up in situations where we define code that doesn't adhere to our personal preferences as tech debt, regardless of its maintainability.
Dude, that totally ruins my experience of changing it.
Right.
First, I have to format it.
You're right, exactly.
First, I have to replace that case statement with some if-elses.
Right, exactly. And I would describe that less as removing tech debt than renovating code. So whereas eliminating risk in the application, suppose your application were a house. I'm very wary of these sort of physical metaphors, but if your application were a house, I think fixing broken windows, repairing the roof, like regrading the basement so it doesn't flood, those are all things that reduce actual risk. Whereas remodeling the kitchen is a different thing, right?
But it might reduce cost of change.
It might reduce cost of change.
Specifically, if you are the developer working on it. So if you come up to a Rails app and you're really good at Rails 5 and this app is in Rails 2, well, that's tech debt for a couple of reasons, but one of them is that you're not going to be able to change it with good effectiveness. Skillfully, you're not going to be able to change it skillfully. You'd be trial and erroring it.
And I think that's part of the initial process when getting into an application that has a lot of risk associated with it, is that loss of there isn't a matchup between the knowledge that is needed to maintain this app and the people who are trying to maintain it. And that can be because the framework is out of date, or it can even be because there's the business case that this app was originally built for, and the person who wrote the app understood the business case very well, and the person who understood the app maybe didn't necessarily completely test it or didn't necessarily completely document it, and then they moved on. They moved to a different team or they got another job, and a bunch of context has been lost because they were the original holders of that context, and now that context is gone. And so now what we're dealing with is an app that functions very much like an abandoned house, the kind that sits on the corner, and there's nothing technically terrible about that house. But because it's so mysterious to everyone, the children on the block think of it as scary and haunted, and they don't want to go inside. And if they do venture to go inside, it's only the bravest kid, and the kid gets 10 steps into the door and like touches something and then hears a creak and runs out screaming. This is where we can end up. And it's not necessarily that something's wrong with the code all the time, it's just the knowledge is not there. And that makes it hard to maintain because that knowledge has to be regenerated in order to be able to make updates to the code. And that regenerating lost knowledge is a very expensive endeavor.
Yeah, yeah. The ability to change the software does not reside in the code. It resides in the relationship between the code and the developers who can change it.
Exactly.
And when that is lost, yeah, that's what I call legacy code. It's code that nobody has a good model in their head about it.
Mm-hmm.
So it's not like in a code plus coder system.
Right. It's out on its own. It's isolated, if you will.
Yeah. Does anybody else have experience with a system that you were supposed to change and it was scary, like an abandoned house? I should look at the chat. Francesco said a while ago that debt is something you're stuck with and want to get rid of. Yes. And back when the tech debt metaphor was coined, that was the general view of debt. Now, in the days of fancy finance, debt is often a strategic choice.
Right. I remembered one time learning in a class about buying debt, and I remember thinking to myself, why would anyone buy debt? Why would anyone want? Why would you pay money? I just didn't understand the concept.
Buying someone else's debt.
Right. It's not. Yeah. Whereas in tech, like you would transferring the debt from one code base to another wouldn't be a good idea even if it were possible, I think, probably.
Ayush, you have your hand up. Do you have a story?
Yes, actually, I do have one. It's quite I would not say old. It happened like 4 years ago when I was working for a client. Unfortunately, the business requirements that were given to us were not quite comprehensive, and the data that they wanted us to manage suddenly started becoming more. It changed from user data to at some point being management of a warehouse data, and the parameters there are entirely different. Like it's a whole different approach that we should have started out with.
Mm-hmm.
And by the end of it, when I decided that I informed my project manager, hey, I'm going to leave pretty soon. Is there something immediate that you need me to explain to everybody or perform a knowledge transfer? The shock on their faces was quite quite a. It was unexpected also, but quite expected in the sense that nobody knew what was happening inside the code except me, because I was handling the whole front end and back end thing, and I had to spend like about 3 weeks explaining how everything was working. And yeah, people didn't like me after I gave that presentation for 3 weeks, because it was quite boring for them to sit through why I did things the way I did things.
Well, good job, like passing on that knowledge as much as you could, because that's a huge part of escalating risk, is that the cost of change depends so much on the individual people, on your historical context that you worked to pass on. And the development is knowledge work. And I don't think the industry or the world or any of us really fully appreciate that yet. How much what we're able to do depends on what we can know, not how many of us there are. Let's see, Chelsea. All right, so we've talked about like what is this escalating risk and where does it really lie? It lies between the people and the code, not just in the code, especially the risk of increasing cost of operations and change.
Mm-hmm.
How do you okay. The question we're supposed to answer is how would you measure this? But I always, whenever I see the word measure, I replace it with the word notice or observe. Because if you start with how can you observe an effect or an amount that you're looking at, later you might be able to turn some of those into measurements.
Right.
But yeah, so how would you notice escalating risk?
I like the distinction that you just pointed out, and I think that you've mentioned, and we have them on this diagram a little bit, some of the ways that we might go about noticing that. I think one of them is outages, like you were saying, where the cycle where the software goes down, it's supposed to be operating a given way that it's not operating, and availability loss, to me, to me, is a potential place to look for a metric. I think bugs as well. I think in particular things that used to work and don't work anymore can be a really important thing to notice here. I also think that developer frustration can be an important thing to notice here, and this is one that I think that you also kind of talk about. And I think,
Oh yeah, because that cost of operations also comes in people.
right, right. So, and maybe to that end, maybe this is the same thing, but I think that churn could could potentially be something to notice on this because developers, when they take a job, they're interested typically. They want to make things better. They want to provide something for people. They want to create value for someone. They want to do something useful. And so that is what is fulfilling for developers. And also removing stuff is fulfilling for developers because it makes them excited about their reduced maintenance.
Who likes to delete code?
Love deleting code. That's my favorite thing.
Me too.
But it's in that middle ground. It's in the struggling to maintain what's already there that I think developers may start to feel this sense of struggle, that it's not as motivating. Sometimes it's difficult and can feel like the absence of meaning in what it is that they're doing. And so developers will only stick around for that for so long, I think, in some cases.
Yeah, sometimes it feels like when we have like a good relationship with the code and we understand it and that we've moved it to a point where most of the architecture decisions are appropriate to its current purpose, then it feels like we're able to add a capability to the business or to the world with in sympathy with the software. But when that other times, like in where I'm right now, it just feels like we're wrestling with it. And every move we make, it makes another one and poof, there's another bug. And that's where your cost of change becomes infinite because, oh yeah, you made the change. It's done. But at the same time, there's another bug that you didn't know about.
Inevitably, I think this kind of happens when you have a mismatch between the way that things are modeled in the code and the way that they ultimately kind of have to go. The way that I think about that is that when we are designing our code to model our domain, we are applying a grain to it, much like the grain of wood. And then later we have to do things to modify it or change it.
Yeah, like Ayush's domain totally changed. Oh, this is about people. No, this is about the warehouse.
Right, exactly.
And then I made
if the
triangles.
original model had been accurate, making that change would be like cutting along the grain of the wood, but it's not. It's like cutting across the grain of the wood, and that's more difficult to do.
Yeah, yeah. And it takes time and breathing room to move from the original way you modeled it, which is never optimal. You got to start somewhere, to your newer, more appropriate, more developed understanding. And if you're spending all your time on overhead, and worse on new changes, then you don't get to like you don't get to refactor the code into an expression of the current domain. And I think sometimes, like, if here's like your day, this is a sun, it represents a day, and like which is the highlighter, this one, if this much of it is overhead of keeping the code running, and this much is new changes, well, all your new changes are increasing your overhead for later. There's going to be surprises, and so then tomorrow you've got this, whoops, wrong color, you only have this much new changes and you've got this much overhead, and pretty soon the overhead is really dangerous. This could be it could be stuff that you do regularly, like deployments, and I don't know what else is regular. I don't know, deleting the log files on the disk if it's really old school. But it can also be the regular surprises. If your libraries aren't up to date, if some of this overhead should be keeping your libraries up to date, because out of date libraries is a major risk. One, it's the biggest security risk. Most of your code is in those libraries. And two, then when it's the risk of when there is a major critical security release because someone in the world has discovered something new, then you have to upgrade a lot of libraries at once, and that's really scary. But if you let your overhead grow, then we get to this ossification of it's all we can do to keep the software running and do these absolute minimum security and emergency fixes. Whereas if you spend some of that time, just a little bit of your time each week, reducing that overhead of let's make the library upgrade smoother and regular, of let's make it so that when the disk fills up, we get an alert that's actually meaningful and we can do something about it. Making your operational alerts meaningful, adding observability, so that the surprises don't cost you as much. Then this is a cloudy day. Then you get the sunny day with, whoops, where you spend some of your time reducing whatever overhead you have and increasing your ability to change, and you get the right trend. It's like if your spending is like 10 cents more than your income, you're eventually going to run into bankruptcy. But if your spending is 10 cents less than your income, then you'll get better, very slightly better over time. That concept of compound interest does work here. Of if you're not spending any time on making your own job easier, then your job will naturally get harder because this is software and the complexity finds itself. And you are eventually doomed to ossification and being unable to change it. And then you get a rewrite, which also never works.
I think this is one of those places where sometimes there is a mismatch in expectations between the software engineers and the business asking for changes, which is, I think it can be easy for the business to assume that once a feature is in the code base, it's free. After that, there's no more work that has to be done on it.
Yeah, they think there's such a thing as done.
Right. Whereas features, they require ongoing maintenance. They require care. They require updating. They require checking on things. And that kind of piece ends up missing. And so as a result, I think in many businesses, there ends up being a lack of accountability for which of these features are still necessary. Rather than which features...
And doing the work of removing them to lower the complexity.
Right, exactly. And eventually you get a higher maintenance load than you need because developers are devoting a disproportionate amount of their time to features that do not provide the value that their keep requires they provide in order to be worth what it takes to keep them.
I like to think of it as with every new requirement or every new user story, there's like this invisible requirement and everything else still works. Because typically any one of those individually is so much easier than like maybe you want 2 views of, I had a cat diary app, and then I made it so that the cats could view the posts. They could either view their own posts and then they'd have like edit buttons, or they could view other people's posts and then they would not have write access. And then there was the ability to delete a post, which was super easy in the version where you could only see your own posts. And it got way more complicated in the version with 2 different post views. And that's so tiny. And yet I could really, it was a great experience of, oh my gosh, I feel it. I feel the factorial impact of every new feature.
Okay.
Liam, you have your hand up.
Yeah, I was actually, that brought to mind something that I've been working on. I'm still a student, so I'm new to this whole thing, but this,
Welcome.
what you're talking about, like implementing features and having to rework everything, is very real to what I've been doing this semester for my capstone project. We're designing a little Internet of Things device, and I find that the way we had our schedule laid out, like our demands, our milestones, was by this week, this feature has to be working, by this week, this feature has to be working. And I noticed I hadn't heard the term tech debt before, but this is very much what we've been doing, is to get that milestone for that week, we find something to just hack that feature in, get it checked off, say we can did it, show it to our project sponsor, and they can be happy with us. Then the next week, I try to add the next feature. I find it's not going to work with the previous one, and so basically for the last 3 or 4 weeks, I've completely rewritten our entire code base, almost several weeks. So how do you have the sort of foresight in a project to avoid this sort of thing, to say, hey, I need all of these features in the end. I need to design my architecture from the ground to incorporate all those things. So I'm not going to have to rewrite the whole thing.
Short answer, you don't, because you don't know what all the features are in real life. You know some of them, and based on experience, you may be able to like design ways that the ones you expected fit in, but there's always ones you didn't expect. And this is where refactoring comes in. So when you say you rewrote your app, when software developers are working under hello, Pixie, without a unrealistic deadline, then we get to refactor the code before we make a change. Kent Beck says, I think it is refactor to make the code easy. No, refactor to make the change easy, then make the easy change. So totally normal to rewrite it to make it possible to add the new feature. Sorry.
Makes sense. I guess as I've been going through, each rewrite has been smaller and smaller, because I learned like, oh, this whole model is not going to work. We're going to redo it, and then the next thing is easier to add in. So it's I guess like you said, you're.
Good. Yeah, that's a good sign if each rewrite is smaller. Cat.
The way, sorry if I butt in here, I mean, the way I would describe it is an engineer never really understands the problem they have to solve until they've actually solved it. And once they've solved it, they'll think of a million better ways to do it. And I think that's probably what you're experiencing right here. And believe me, you've got it in college, it won't go away once you start working. It's a rewrite is a part of it, and it will never, ever go away. Yeah.
Sophie.
Cool, that worked. I wasn't sure where the raise hand button was, but then I found it. Hey guys, so you mentioned earlier that one of the first steps towards resolving and removing risky tech debt is observing it. And you talked about how some of the things that you look for are, maybe like incidents occurrence, how long it takes to resolve incidents. So I'm curious, what other metrics do you look for that help signal to you that we're going to really benefit from investing now and reducing tech debt?
Oh yeah, good question. Can everybody put stuff in the chat for what they do for noticing when there's some escalating risk in the code base that they'd like to mitigate?
This
I know
is a-
when, go ahead, Chelsea.
Yeah, I'm interested to see what folks say in the chat and how that differs from some of the processes that I've seen. I think that Jess spoke to something that I have also found earlier with regard to experience giving you an idea of how things might need to be shaped as things change. I think that one of the big things that really helps in conceptualizing a design at the beginning of writing any kind of software is to think about how it is likely to change in the future. We like the idea of making things easy to change everywhere, but the idea of making things easy to change everywhere is
That's called overgeneralization.
well, right. And, you know, if you have a ball of dough, you're only going to be able to stretch it so far in every single direction. And so at some point, you kind of have to pick a direction and say, all right, well, making it easier, making it more elastic in this place is going to make it harder to stretch in another place. Making something, I have to focus and I have to prioritize on what's going to be easy to change. Because then the other places have to carry the complexity of going against the grain of the way that the software is designed. And you hope that you choose the places that really do end up undergoing the most change to be the easiest to change. And it's everything from whether you want to use like a function-based approach to an object-based approach in this particular part of the code base, or even down to language styles or APIs that you want to use. It's part of your decision-making process. But I'm working with a team now that's had a code base for a very, very long time. Like before we all had cell phones, long time. And which isn't a long time in terms of human life, but in terms of the tech industry is a long time. And so there are a number of things about that code base that don't match up with the way that kind of modern standards might expect them to be. So one of the things that we have started to do as a team has been to begin cataloging the features and understanding which of these features are regularly used by the people who we are here to help. And which of these features cause the most incidents, which of them cause the most outages, which of them cause the most calls to support, with the idea ultimately being that we can figure out how much each of these features roughly is costing us in terms of maintenance and how much benefit they're providing.
Oh, and your error.
Go ahead.
Like your error events from
Right.
production.
Mm-hmm. With the hope of figuring out what all the different features keep is and whether they're worth that keep. And we'll see if that works, but I'm hopeful. A big part of that is getting people to log when a ticket is taking longer than expected. Why is it taking longer than expected? Not to make them feel bad about the ticket taking longer than expected, but rather to hold the code accountable in those cases where things are difficult. Because I think it's very easy to lose that data. And it ends up being like a hunch on the developer end. Whereas having it documented can be a helpful indication of what really deserves our investment of time on becoming easier to change. Where do we want to put those yellow parts of our day? Where in the code base do we want to invest that?
Yeah. RD Star, who gave me the escalating risk phrase, she counts WTFs. She's got an IDE plugin where you can like push a button to be like, whenever you hit a surprise or a confusion point, so that you can look back and say, okay, which pieces of the code repeatedly surprise us or confuse us?
I like that idea.
Error events and error budget. Yeah. Don remarks that it's the definition of architecture to make things that are likely to change easy to change. Also design, it's a blurry line there. But Chelsea, you talked about software having a grain and that some changes are across the grain. And something you don't want to do is try to avoid having a grain. Because if your software can support any change, then what you've written is a programming language. That grain expresses the domain that the software is solving. It expresses the business knowledge that you've encapsulated in the software to help the people who use it and configure it to do it right.
I think that's a good point. We think about grain in terms of wood and woodworking, but there's also the fact that the reason that a grain exists, the reason that there is a grain, is because that's what supports a tree getting as tall as it does. Plants without grains don't get nearly that big.
Yeah. Flaky tests. There's a huge one. If you have a flaky test, you have tech debt because you don't know why that test is flaky. And a lot of, and that is one of the clues, like the WTFs, the points of confusion, that there's a knowledge gap between our model of the code and what's really happening. And because this risk/tech debt exists in the relationship between the person and the code, that knowledge gap is a flag. Nobody ever wants to look at the flaky test because, well, if you could reproduce it, it wouldn't be flaky. But somewhere in there is a surprise that when you find it will increase your understanding of either your code or the runtime or some aspect of your system.
Right, exactly. There's a mystery variable in there somewhere. And so far, as long as that test remains flaky, that variable has remained a mystery.
High mean time to repair, or if it takes you a long time to figure out what caused an error or an outage. There's an indication of the model again. Conrad said you could look at complexity using tools like Reek or other, or in Java apps, there's Sonar Cube, and you can have automated tools that have opinions on your code. They're just opinions. Sometimes that case statement is expressing something important.
So I had a question. Like, how important is it to figure out the right architecture early on in the life of a project, based from the perspective of risk?
It's really important and also impossible. With these changes, that's an excellent question. Whenever I'm making a decision, like what platform am I going to run this on? Am I going to make this an environment variable or just hard code it, which is always usually tech debt, or am I going to put it in Vault or something somewhere? When you hit one of those questions where you're like, I know there's a best practice way to do this, and also I want to get my job done today. Think about how will you change it later? Because if it's going to be, of course, if it's going to be the same amount later, whatever, do it later. But if it's going to be 10 times as hard later, fine. If it's going to be 20 times as hard later, fine. That's a fixed number. But if it's going to be n to some power times harder later, where n is number of features, number of developers, number of customers, anything that I want to increase, then think about it. Okay, so like if I don't do authorization correctly or as best as I possibly could right now, how hard is that going to be to change later? And if it's going to increase with their number of customers, then maybe change it soon. Okay. Get that on a JIRA card and get that to your product owner whose job it is to know these risks and recognize the business risk in that so that they can make it a priority. And finally, if it's going to be once somebody uses it, we can't change it, like a public API that you're going to have to be backwards compatible to, don't do it now. Don't skimp it on that.
I would agree. If you're starting out with something very small, but there are things that are going to scale in difficulty to change with the way that you are hoping your app is going to scale, that is a high priority thing.
That's shooting yourself in the foot, yeah.
Right. Because then you have a conflict of interest on like the success of the software, which is not great.
But sometimes you have to wait if you're like in an MVP stage, but you can put a limit on that. Okay, if we hit 100 customers, we got to fix this before it goes any higher.
Yep. I'm a big fan of setting a limit ahead of time like that, because otherwise you can keep moving the goalposts according to what's convenient.
Yeah. But at the same time, so much code never gets to production. that sometimes this tech debt is actually free.